Hello everyone. This is a very nice problem which needs correct explanation because most of the solutions that I have seen of this problem are not up to the mark. So I have taken it as a responsibility from my end to explain it satisfactorily. So let's read through the problem once. A rope of mass m is hung from a ceiling. This rope will have mass uniformly distributed. So the weight of the rope, though I will show it at one point of time acting at the midpoint, but this will be a distributed force because the mass is distributed. The center point is pulled down with a vertical force capital F. The tangent to the rope at its ends makes an angle alpha with horizontal ceiling. These alphas are given in the problem. The two tangents at the lower point make an angle theta. If no force F is acting, then this theta should be ideally equal to 180 degree because the two tangents will be making 180 degrees and the tangent will be horizontal at the lowest point. But because of the application of the force F, this angle reduces to theta from its previous value of 180 degree. So we will proceed with this problem in two steps. In the first step, we will draw and analyze the free body diagram of the complete rope, and in the second step, we will go through the equilibrium of the half rope. So we have the diagram. I have shown with red color the weight of the rope at the midpoint, though it is a distributed force, but at all the points it will be acting in the vertical direction. So for vertical equilibrium, it will work very fine. Now T1 are the two tension forces at the two extremes at the upper end, and T1 can be resolved into two components. This angle will also be alpha. So the vertical components will be T1 sin alpha and horizontal component will be T1 cos alpha. Similarly, this end T1 can be resolved into T1 sin alpha and T1 cos alpha. Now T1 cos alpha will get cancelled, so there is no problem with regard to the horizontal equilibrium. For vertical equilibrium, we can write that 2 T1 sin alpha, this value should be equal to capital F plus mg. So this gives us the first equation. Now let's go ahead with the free body diagram of half of the rope. So half of the rope is like this, and at this end, at the topmost end, two components of T1, that is T1 sin alpha and T1 cos alpha, are acting like this, and at this end, let us say T2 is acting like this, and half of this angle will be theta by 2, and so we can say that vertically opposite angle, this will also be theta by 2. So T2 can be resolved further into two components, one along the horizontal and one along the vertical. In the vertical direction, T2 can be written as T2, component of T2 can be written as T2 cos theta 2, and in the horizontal direction, T2 sin theta 2. Now for equilibrium in the two directions, for horizontal direction, we can write T1 cos alpha as equal to T2 sin theta by 2. Let us call this equation number 2. And for vertical equilibrium, we can write 2 F equal to, in fact, if you watch closely, this tension T2 is due to the application of F only. So the vertical component T2 cos theta by 2 is definitely due to F. If F is not acting, the tension will be horizontal at that point. there will be no vertical component of the tension. So we can say that F should be responsible for twice T2 cos theta by 2. This point is very important. You imagine there is no F acting at the midpoint of the rope. If no F is acting, then the tension acting at that point of the rope will be completely horizontal, so there will be no vertical component of tension. So that implies that at the midpoint, the vertical component of the tension from the left end and the right end, we are strictly talking about the midpoint, they must be equal to and supplied by the external force F. That is why I have written this equation. So let us call this equation number 3. If I divide, I get T1 cos alpha by F as equal to tan theta by 2 by 2. Let us call this equation number 4. And for T1, we can use equation number 1. So T1 we can write as F plus mg divided by 2 sin alpha. F plus mg divided by 2 sin alpha. So F plus mg divided by 2 sin alpha multiplied by cos alpha by F, and this value gives us tan theta by 2 divided by 2. So we were required to find the value of theta. In fact, now it is quite clear. If I cross multiply, I think 2 will get cancelled. So theta we can write as 2 times of tan inverse of F plus mg by F and into cot alpha. So this is the final answer. I hope you get it. You can go through the solution once. This is a very nice problem. Thank you very much.